This is the second video under the topic mole concept in the chemistry tutorials. Where we left off in the last tutorial was we did Avogadro's number, Gay-Lussac's law, molecular weight, atomic weight, and now we're just going to start off with a concept called atomicity. Now, the definition of atomicity, I'm just going to write it here. Yep, so atomicity is basically the number of atoms present in one molecule of any element. So let's take the basic examples first. Atomicity. So let's take oxygen. Now we know that two oxygens will combine to form an O2. Now we can also take the example of H2. Under bonding, you would have come across the bond formation of H2. It would be a covalent bond, something like this. So as you can see, its atomicity of H would basically be how many atoms of H make up this molecule. So it's clear here, there's 1 and there's 2. So the atomicity of H2 is 2. Similarly, it's also 2 for oxygen over here. Now when we talk about metals, let's take calcium for example over here. Now Ca, one molecule of Ca is also just Ca, which is equal to one atom. So any metal, the molecule of that metal will be equal to just one atom of it. So this is equal to one molecule of Ca. It's also equal to one atom of Ca, but it's more appropriate to write one atom. So as you can see, one molecule has one atom, so its atomicity is just 1. Now you have certain elements which are polyatomic. You can guess from the prefix poly that it would mean that their atomicity is more than 2. So examples are there's phosphorus, which is P4, so you can see atomicity is 4. Sulfur is S8. Yeah, 8. I haven't got it wrong. It is 8. You're probably wondering how, but at your level, I don't think you should know. It's gonna confuse you further. And there's also O3, which is ozone. Okay, so you can see the atomicities are 4, 8, and 3 respectively. So these are called polyatomic. The elements which have atomicity 1 are called monoatomic, while the ones like O2, H2, also N2, you could say Cl2 as well, all of these are diatomic. So that's all there is in atomicity. Now coming to another concept, it's called vapor density. I'm just gonna write VD for it. By definition, it is the ratio between the mass of a certain volume of a gas divided by the mass of the same volume of hydrogen. So let's just take any gas here. Let's say we take O2, and below we have to take H2. So the vapor density of O2 would be, let's take any volume. So let's take 22.4 liters. As we know that if we take 22.4 liters of any gas, it'll turn out to be 1 mole of the gas. So 22.4 liters O2 upon the same volume of hydrogen, so we have to take 22.4 liters H2. So we know that this is equal to 1 mole O2 upon 1 mole H2, and here we're talking about the mass of 1 mole. So mass of 1 mole H2, we did this in the previous section. It would be the mass of O plus the mass of O. It comes out to be 32. In the denominator, we'll be doing 1 plus 1, which is 2. So here you get 16. Now a formula that'll come of use to you later in the chapter, you'll see, is yeah, I'm gonna write it here. Molecular weight mw, that is equal to Vd, which is vapor density, into 2. Now let's just verify this formula using the above example. So molecular weight of oxygen should be equal to the vapor density, which is 16, into 2, and it comes out to be 32 grams, and you can see that the molecular weight of oxygen is 32 grams. So this formula does hold true. Now there's another very important concept. um, it's called percentage composition. So just to brief you on it before I start discussing it, uh, when you take any compound, it's made up of certain elements. Now uh, you can take the mass of each individual element and find out that how much percent of the total mass do they make up. That is basically what is percentage composition. Now I'm gonna take CaCO3 as my example, and the reason I'm gonna do that because it's simple. Its molecular weight adds up to 100, so getting the percentages is pretty easy. You'll see right now. So in this, the Ca weighs 40. There is one C, so it weighs 12, and there are 3 O's, so it weighs 3 into 16 and you get 48. So you can see they add up to 100. Now the formula to find percentage composition of any element in this compound, it would be weight of that element, weight of element divided by the total molecular weight. And since it's percentage composition, we're going to multiply it by 100, so we get a percent. Now let's just do for Ca first. Weight of element we found out is 40, total molecular weight is 100, and into 100. So this is the reason why I took CaCO3. It's because these 200s here will cancel out and you're left with 40%. So similarly, the percentage composition of C will be 12% and O will be 48%. So it's an easy concept. It's just perhaps the only tricky part would be that uh, when your molecular weight is something else which is not divisible completely, you'll have to do a bit of calculations. But again, remember that in chem, it's the concept that they're looking for. So the next thing is molecular formula and empirical formula. So I'm just going to differentiate between the two. Molecular formula you already know. Molecular formula of say C2H6. There's a compound you'll be doing under hydrocarbons. This is the molecular formula. Now empirical formula basically means that it tells us the simplest whole number ratio of the different elements in one molecule. I'm going to do this one for you so that you know what I'm talking about at least. You basically need to try and divide these two numbers by a common divisor. So here you can see that 2 goes into both, so you can divide both of them by 2 and CH3 becomes your empirical formula. Also, let's take another example now. Let's take benzene, which is C6H6. Again, cancel both of them by 6, so your empirical formula is CH. We can take C4H8 as well. So if you got the hang of it now, you could figure out that this is CH2. It's a simple concept, and usually you'll see that in your exams that most of these compounds will all be hydrocarbons. Hydrocarbons you're going to learn in the last chapter. The compounds are made up of hydrogen and carbon, as the name suggests. And the reason why they'll give those is that only they have these large numbers like 4, 8 over here, 6. These are the ones that cancel out, while say a compound like CaCO3 over here, you can't really cancel anything. It's already in its simplest form. So you'll see many of those, and what the question will say is that it will ask you first something about the empirical formula, and then it's going to link that question with hydrocarbons and ask you questions on that. Usually it comes in section B for I think 5 marks. So it's scoring. If you know hydrocarbons well, you should know this very very well. So moving on to the next part. A few more terms that you should be familiar with. One is relative atomic mass. I'm going to abbreviate it to RAM. This is basically relative atomic mass would be the mass of any element. The mass of any element, I'm writing that as m, upon the mass of one atom of hydrogen, which is always 1 amu. So it's basically the mass of an element. Now if they ask you relative molecular mass, that means it's the same thing except the mass in the numerator will be the mass of a molecule. So say over here you had O, then over here you'll have O2. So again you divide it by the mass of one atom of hydrogen, which is unity, so it's 1 amu. So you'll get this in basically in amu. You'll find the weight of that certain element or that certain molecule with respect to weight of hydrogen. That's why it's called relative. Also, when you express both of these in grams, it's called gram atomic mass and gram molecular weight, respectively, or gram molecular mass also. That's interchangeable, but always be careful about um, whether they're asking for molecular or atomic. This is where I lost a mark in my board exam. So okay, so now I'm just gonna do a few questions on this. There are quite a few numericals, so I'll just be going through them. I'll be continuing with the questions in the next tutorial.